Hello everyone, welcome to my U Programming Club. Today we will be solving another daily Leetcode challenge, and the challenge name is Combinational Sum Part 4. So the problem statement or the challenge statement, given an array of distinct integers and the array names is nums and target integer target, return the number of possible combinations that add up to target. So the test cases are generated so that the answer can fit in a 32-bit integer. That's the problem statement. So for example, if the nums array is given to be 1, 2, 3 and target is given to be 4, so these number of combinations are possible which can add up to 4. So as you can see, the number of combinations is 7, so the answer is 7. And the thing here to be noted is that different sequences are counted as different combinations. So the constraints are as follows. The nums length is of order 200 and value in the nums array are of order 1000, and all the elements in nums array are unique, and target value is of order 1000. So let's try to solve the problem. First, we will consider applying a brute force approach. What you can do is, when you are given a nums array and the target sum, let's say the length of nums array is n, and so if there is the nums array is something like this, then the overall time complexity of this brute force approach will be in brute force approach. What you will do is uh, you will make recursive calls to a function. Let's say solve will be target nums. Basically, all those numbers in the nums array which are lesser than the target's current value will be considered. So overall order of n raised to power x number of combinations will be generated. This is a upper bound. Time complexity will be this, and the space complexity, since we will be making recursive calls, will be x. So you may ask when this will happen. If let's say target is given to me 4 and there is one present in the nums array, then it can be like this, and so on we can continue. So this will be the upper bound of time complexity, and this will be the space complexity. So n here is of order 1000, as you can see. and here is the sorry, and here is 200 raised to power, and target is 1000. Upper bound of this number of operations will be required to solve it in a recursive way using this brute force approach. Number of operations required. So these number of operations, let's call them ops. So the ops value will be very much greater than 10 raised to power 8 operations allowed in 1 second. So it will give us TLE and our solution will not be accepted. So this limit is, I will be providing a link of an article describing how the time complexity of accepted solution varies according to input size. Basically, in 1 second, or there is a limit of 10 raised to power 8 operations. And if the solution that you are proposing is requiring more than or equal to 10 raised to power 8 operations, then your solution may get a TLE and it will not be accepted. So in order to get a accepted solution, we have to optimize this brute force approach. A thing here to be noticed is that, let's say, if some target X is given to you, and when you are recursively checking for the number of combinations, you arrive at a state where the target's value is 4 and some number of combinations resulted in a combinational sequence resulted into 4. Let's say you choose 2, 1, and then you again chose 1. Then you ended up at this 4. Now let's say there was another combinational sequence that resulted into 4. Let's say it was 1, 1, 1, 1. So there are two combinational sequence that resulted in a particular number, and so you will, let's say, beyond for the numbers beyond 4, let's say it's 4 plus x or something, 4 plus y, some value. You will be doing calculations for this 4 again and again. One every time this 4 is encountered. So to avoid this extra work, this is we doing extra work. Which is being generated due to overlapping subproblems. Also, it is to be noted that to find the number of combinations that can result in 4 plus y is any positive number you like to take. You are dependent on the result of 4, or the number of combinations that result uh, in a sum of 4. So another condition here is satisfied that a bigger problem big problem. This is a big problem, let's say, and this is a smaller problem. So big problem solution dependent on all problem solution, and solution of many such small problems can be combined to form the solution for bigger problem. Solution for smaller subproblems can be combined solution of bigger problem. So these are the two observations that we are making. First is overlapping subproblems. Due to overlapping subproblems, extra work is being done. And the second one is optimal substructure. Here the solution for smaller problems can be combined to form solution for bigger problem. So these two properties are, or say observations are being made. So approach of dynamic programming can be used to solve this problem, for which two necessary conditions need to be satisfied. First was overlapping subproblems. Second was optimal substructure. Those of you who are new to these two properties, I will be providing a link of an article describing these two, and a link of an article describing this approach also, dynamic programming. So you can explore those articles and then you will be able to understand why we are applying this particular approach here. It's just optimization over brute force. What you will do is you will store the results for each state you encounter while forming solution. It will save extra work. And what you will do is you will use solution of smaller subproblems to build a solution for bigger problems, or say bigger subproblems. These two things you will be doing. What I mean by this state is state here is nothing but the sums value, or say target's value at a particular instance. It is state. So let's say you uh, stored somewhere that how many number of combinations will result into 4. How many number of combinations will add up to 4. Then you can easily uh, use this result, stored result, when you encounter this 4 again in some another sequence. So it will save you extra work, and then you can use the solution of 4 to build up the solution of 4 plus y. It will uh, use this property optimal substructure. So these two things can be done. So the overall time complexity of such approach will be, let nums of array of length n and target be x, then the overall time complexity will be uh, n into x, and the space complexity that will be used will be O of x. So let's have a look at the implementation of this approach. And since n here is of order 200 and x is of 1000, so it will be 2 into 10 raised to power 5, which is lesser than 10 raised to power 8 operations. This is the limit. So your solution will be getting accepted. So let's have a look at the implementation of the approach. This is the structure, or say array, where you will be storing the results of a particular state that you will encounter while forming a solution. State here is nothing but the value of target, or say sum, at a particular instance. So initially, for the value, for the sum value, or say target value equal to 0, there will be one possible combination. That would be not taking any of the numbers in the nums array. Since the numbers are starting from 1 to 1000, it can go up to 1000. So that's for that case. And then for each current value of sum, you will add the contributions of previous states or sums that could have lend that could have landed us on the current sum. Sum here is nothing but the state. So if the value of a number in the nums array is lesser than or equal to the current value of sum or say state, then it can be considered as a previous state for the current state, and it will contribute to the current state. So we will be adding the contributions of the previous states. And thus forming solution for current state. And at last we will return number of combinations that could have added up to target. So that's pretty much it. The code will be available in both C++ and Java. Let's try to submit it once. As you can see, it's getting accepted. So thanks for watching. And before ending the video, I would like to mention that if you are having any doubts or queries, please feel free to ask them in the comment section. I will be more than happy to answer them. Thank you for watching. Thanks.